Hello, everybody. Welcome to our Telescope Talk Hangout. We do this every 2 weeks, and it's hard to know exactly what to say. Is it this month? Is it this week? But anyway, welcome to our Telescope Talk Hangout. My name is Tony Darnell, and today we are going to be talking again. We're going to be revisiting this topic of image processing. And in particular, we're going to be talking with Kevin Gill. He was a software engineer at JPL who does a lot of image processing, quite lovely stuff. So we're going to talk to him about maybe get some tips and techniques, and we'll talk about a software that he uses, how we got into imaging, and everything else. And so welcome to our latest hangout. Now, for those of you who don't know, we are trying to get you into amateur astronomy. So if you're interested in buying a telescope or doing something related to looking up in the night sky, then this is the hangout for you. We want to offer you tips and advice, and all of us are amateur astronomers, and we have lots of advice to give, whether you want to get it or not. So please interact with us. Please ask questions. Couple of changes this time around in the streaming situation. I'm only streaming to YouTube these days. I'm not going to the other platforms. It turned out to be more trouble than it was worth. And so I'm only streaming to YouTube, but I would appreciate it if you guys could watch this on deepastronomy.space/live, or if you're on YouTube watching this, then we then use the live chat feature there. But if you're on Deep Astronomy, you're using our Discord channel, our Discord server, and that is also a nice thing that helps support Deep Astronomy. How does it support Deep Astronomy? Well, it turns out that I did some SEO stuff on my site, some search engine optimization, and I need backlinks. I need people to link to Deep Astronomy when you can. That helps my site in the Google search engines. So if you would like to support the work we're doing here, one of the ways you can do that is by sharing out the links to the web pages that these events are on. And if you go to deepastronomy.space, you'll see this particular event, although the live chat won't be enabled quite on that. So anyway, a couple things that just a couple small changes. I'm looking at the live chat, so if you want to ask questions, lots of people are already here, but my co-hosts are also actively watching the live chat on Discord as well. So we'll get to your questions and comments, and let us know what you want to, let's dive into processing. So let me bring up everybody here, since it's just me right now. Let me go here. There we go. Hello, everybody.
Hello.
I see you all there. Okay, I'll introduce you. There are 4 people on that side of the Brady Bunch screen. We have in the top left Alexander Reinders. He's from Germany and does a great job. Has a lot of amateur astronomy equipment. We've talked about a lot of his stuff before. He's also a good image processor. In the upper right is another amateur astronomer. He's from the UK, John Suffel. Hi, John. And yes, it's pub time, or it's pint time in the UK and Germany. And here I am in the United States, middle of the day. I'm not day drinking yet, but I probably should be. And the lower right is Adam Smith. Adam Synergy, for those of you who follow him online. He's also in the UK. So these guys are enjoying their pints, while my guest is Kevin Gill in the lower left. He's from JPL. You're in California, right, Kevin?
Yes, I am.
Okay, so I don't know. I mean, for you, it's about what? It's only lunchtime for you, right?
Yeah.
So I suppose we should wait to get our pints out. But anyway, thank you for.
Time's good.
Yeah, whatever, right? I mean, may as well. Okay, so
always be a time somewhere.
That's right. It's 5 o'clock. I say that all the time, and my wife hates it. But it's right. It is 5 o'clock somewhere. So anyway, I just got my iced tea here, and I talk about the weather, but I think I'd make all the people from the UK angry because they're having really crappy weather right now. So we won't do that. Okay, so Adam, how could you please introduce our guest? You were the one who was able to contact him and invited him here. So please give our viewers an introduction.
Sure. Our guest today is someone whose work I've followed via social media for quite a few years, and he really is a superstar of the astro imaging world. He's done some spectacular, beautiful images of the Saturn system with Cassini, and data from the Mars orbiters and rovers, as well as Hubble, all sorts of things. I think you shared a put a link to his Instagram and
Yep, it's in the description box in the video as well.
So I suggest you do yourselves a favor and go take a look at that.
Follow him on Instagram, and can you follow people on Flickr, or how do you?
You can.
Yeah. Okay.
It doesn't do much. It's a matter of keeping a link.
Definitely do it on Instagram. So give him a follow on there. It's definitely worth your time. Okay. Were you done, Adam?
It's Kevin Gill.
Okay, there we go. Thank you. All right, Kevin. Hi. Let's start. Now you're a software. So I read your Instagram profile, and it says software engineer, and you're a climate and planetary data wrangler at JPL. Now I'm going to talk to you about this a little bit more in the hangout. It sounds like you did an awful lot of things that's very similar to what my job was at in solar and cosmology, solar physics, and in cosmology. But we'll talk about that a little bit later in the hangout, because I'm interested in what you're doing at JPL. But so image processing is the focus of what we want to talk about. Give us an idea of how you got into processing images, and also maybe talk a little bit about, are you an amateur? Do you have telescopes? And if not, why not? Just give us a little background.
Getting into it, I started basically doing computer graphics through a renderer I had written. And then when I moved into Blender and eventually Maya. But at some point, I'm not sure what the trigger was. I think it was at the time a lack of telescope, and I wanted to actually do some photography. I just needed to find some camera that was out in space, and that was at the time initially the high-rise context camera. I did 1 or 2 images with that at first, and then I moved on to Cassini just because the accessibility of all the raw images made it a very good jump-off point and way to learn how to do it.
Okay. Okay. Sorry, I was adjusting some sound levels because people were saying the sound was low. There's going to be a bit of a hum. That's why I have it low. If you hear the hum, I can't. One of my adapters is messed up, so you have to tell me what you'd rather live with. Okay, Kevin. So let me get this back up. With the you said something about rendering. You got into it first of all with rendering and computer graphics. Are you talking about things like there was this program a long time ago when because I did that too, and I'm hearing a lot of parallels between you and my interests. But did you get started to something called POV by any chance? It was a renderer, it was a ray tracing software. Had you heard of that?
I used it like once. Pavray.
Pavray, that was it. Thank you. Yeah.
Yeah, powerful tool. I actually used it as a little bit of inspiration for the renderer I'd written. But over time, that renderer that I'd written just wasn't up to snuff, just because, I wrote it and I'm just one guy. So I had moved on to using Blender and then Maya, just because those gave it a little more modeling capability than Pavray.
Right.
Learning curve was a little easier too.
Yeah, and Frank Summers and Greg Bacon at the Space Telescope Science Institute use Maya, and it's really quite powerful. Apparently, that's what they use in movie studios, right? For rendering things. Now, you can use that, folks, to render data. In fact, if you look at the video I published in January on the Orion Nebula fly-through, that was done with data from Hubble and Spitzer, and Frank and Greg and et al. At the Institute layered that data up in whatever way they deemed scientifically valid, and were able to make it into a 3-dimensional fly-through, and it's really quite gorgeous. So there's a lot that you can do, even though a lot of these ray tracers and renderers are usually for models and making CGI effects. You can use scientific data in them, and so and that's becoming highly popular now, especially among professionals. And to hear that Kevin is now using Maya at JPL, it shows, and they're using it at the Institute with Hubble data, you get an idea that it's really good for scientific visualization. So
Yes. In fact, I was able to take the digital terrain models coming over to the HiRise project and bringing those into Maya and creating actual, almost photographic scenes.
the what models? I'm sorry.
The digital terrain models.
Oh, the terrain models from HiRise. Okay, yes.
Yeah.
And so, well, let's talk about this data. What data sets do you use? And then I'm going to ask you what your favorite is. But what data sets do you generally work with?
I generally work with imagery from Cassini, from Galileo and the Voyagers. I've tinkered with New Horizons, and then I work with the digital terrain model and the ortho imagery from HiRise. Most recently, I started playing with some Hubble data. Tried a couple things, but, which look pretty good, I thought. But I'm not very far with that yet.
Okay, well, is that because you're just not you're not familiar with the archive that you get the data from, or is it something else about the data itself that is there a learning curve with that data versus what you're used to using?
Not much of a learning curve. It's structured the similar way, the way they do grayscale filtered imagery.
Okay.
It's just a matter of just finding a pipeline or a process that fits and works for me.
Right.
They
Now,
look pretty good to me, Kevin.
so the reason we're talking about this, folks, now, and the way in which we're doing it is these data sets are available to you right now. Okay, you can get, and then we've talked before about Juno data with Gerald Einstedt a couple of hangouts ago where he was working with that. But all of these data eventually become available on the various NASA archives. Now, the Hubble data, as we've told you many times, and the Spitzer data, and I think even New Horizons data is all on the MAST archive at the Institute. What data sets now, but JPL data sets are not housed there, are they? Do you guys house all of your data in California? Do you have an archive, a portal to go? Like if I wanted to get, I don't know, HiRise data or Curiosity images, where would I go to do that?
Most of it's on the Planetary Data System, the PDS.
The PDS.
I'm not sure where it's housed specifically, but yeah, that's where you can search the majority of NASA imagery.
Now, and you're just to be clear, you're not
full.
using anything weird that only you have access to, right? You're using data that anybody can get, right?
Yes.
Okay. Now, is there any learning curve to getting this data?
Not so much. The initial data is easy because once you figure out how to do the searches and whatnot, you'll get the browse images, which are of decent quality. The learning curve may come with the actual processing the calibrated data that are in the PDS formats or the other ones,
right?
Or any kind of funky formats.
So that's something I want to get into here, and then I want to show some of your images. With Hubble data or Space Telescope data, you get the data in what's called a FITS format. That stands for Flexible Image Transport System, and I got it wrong once. So, but that's it's a data file system that NASA had invented back in I think it was the 60s or 70s. It's really old, but it's very good at what it does. And so all scientific data are in this format. But they come at you, as we've talked about many times in these Hangouts, raw data is not very nice to look at. It has to be calibrated. It has to be run through processes that get rid of instrumental effects and cosmic rays and all of this other kind of stuff, which we're going to get into in just a little bit. But once you've got the data itself, then you can start working with all of that stuff removed. Then you can start working on the images themselves. Is the data and my question to you is, I guess, as your JPL hat on, is the data from, say, Curiosity that it downloads, or even from HiRise or Maven or any of these other Mars probes, or even New Horizons, is there anything different about that data versus a deep sky image of the Orion Nebula? I mean, for example, Curiosity takes an image of a mountain range or a landscape. But Hubble doesn't do that. Is there anything different? Like, the artifacts that have to be removed or calibrating procedures that have to be removed with that data versus a deep sky image?
It's going to be camera by camera, because the cameras and instruments are also different. But a lot of them you're going to be dealing with cosmic rays or high pixels. You're going to need to be doing flat field and geometric corrections. How much and which one specifically is kind of on a camera by camera basis. I know from working with Hubble, though I'm pretty new with it, it seemed to be pretty similar in how I would approach it.
Okay, but the reasons for calibrating that data the way they do, removing the dark current, which we've talked, the dark field that we've talked about, the flat fielding, which we've talked about, the cosmic ray artifacts, all of that is so that when you put your cursor over a pixel and you read a number, that number has a scientific value in units. Usually it's flux, but it might be energy per unit, steradian, or it might be any kind of unit that whatever the instrument took. But
Yes.
but when you're looking at I don't know, I guess when you're looking at a picture of a rock from Mars, that's not the same, is it? You're not looking at flux, you're just looking at a rock. So those numbers don't have scientific meaning, do they?
Honestly, I'm not sure how the scientists interpret the imagery or the image data. I know that the mass cam is narrowband filters, so there is some interpretation that can be done. But as far as what the scientists use that data for, I'm not sure.
Oh, okay. All right then. All right. Well, let's go ahead and talk about some of these images. So, how should we start? Let me show a couple that that Alex and Adam gave me. First, I want to start with this. Let me get rid of all this stuff. Get rid of that. Get rid of that. Okay. So this was an image I think that Alex or Adam put up.
Mm-hmm.
What are we looking at here?
So that's Mimas, moon of Saturn, that's a tough one to process because it's so small and Cassini was always moving so quickly relative to it. Looking at it, I think that's an expanded spectrum view, if I remember correctly. So it's using infrared, green, and ultraviolet filters. And so the moons with that tend to using that kind of color scheme, at least the way I process it, tend to trend towards the greens. And on the right, you can see it's pretty faint, a little bit of Saturn shine.
Is that what's causing that illumination? That's really cool.
Yeah. So that's just light that's bouncing off Saturn and hitting the other side of the moon.
Okay. And when you got this image, did you have to do any? Did you also have to worry about getting the darks and the flats, or did you just or is there a data product that already has all that removed?
You can get the data product with that removed. I tend to be kind of picky with it, so I'll run the calibration myself.
Yeah, most data processors are. They're going to do it all. Yeah, I know you've done it, but I want to do it too.
Yeah.
Okay.
And I'll be using the actual Cassini issued Syscal process anyway for it. So
Cassini data is it stored in FITS format as well? Do you get FITS images?
It's closer to like a Vickr format, I believe.
Say it again, please.
It's closer to like a Vickr format for PDS.
Oh, I don't know this one. What's that?
It's just another kind of raster-based or bitmap-based imaging format.
Oh, okay. All right. Well, and so is it more like a JPEG without compression kind of thing?
Similar.
Okay. All right. So when is there anything about getting, so when you go to get Cassini data, you go to the data system that you were telling us about earlier. Do you select first that you want Cassini data and then you want object data, or is there can you just query from the homepage the object you're interested in? Yeah,
the easiest way is you pull up the PDS Atlas tool, and you can do searches by a number of different facets on that. The easiest one is just to choose Cassini. Then you can select like which instrument, and typically I'll just choose ISS, which is the imaging science subsystem of the camera. So you can narrow it down to the wide angle or narrow angle, and then you can choose which body you want to search on, Saturn itself or any of the moons or rings.
Okay. With an image like this of an extended body like a moon, does Cassini take several images in rapid succession at a short wavelength that are then co-added, or is it just one image at a certain exposure and that's it? Because I know this is a spacecraft and it's moving around really quick. So
yeah, this would be Cassini has a grayscale camera, but with the color filters placed in front of the sensor. So this one, they would take if this is the expanded spectrum one, they would take a picture in the infrared, move the filter wheel to green, and then take another exposure under ultraviolet.
Okay.
Which would then need to be assembled.
Okay. I want to put up this image. What the heck is this Jupiter?
That is Jupiter. Not my image, but that's from Juno. And that's Jupiter's south pole with all their storms, and they've applied some kind of a height map on that. I'm not sure. I'm not too up on the specifics of this particular image.
Okay.
Tons of processing on that.
I know that's what Gerald kind of led us to believe, is that when you get this Juno data, the adventure has only just begun, because you've got a lot of work that has to get done. That is a complicated data set for a lot of, and that's even with the Juno Cam, which is supposed to be the public outreach camera.
Yeah.
So now I just picked some images at random. Alex and Adam, if you got something specific you want me to show, or you want to put it up on your screen share, just go right ahead and jump in. What about this one? I like this one.
So that's Venus, and that's kind of a composite of two different exposure observations.
Taken at the same time?
More or less, within a couple hours of each other.
Okay.
On the left, you'll have Venus, and that's infrared, green, and ultraviolet, I believe. It's been a while. And then on the right is more of an infrared view of the cloud tops, and I just kind of match the geometries of them and blend them in.
Okay, so this is just more of an artistic kind of image and then a scientific one, because I can imagine these. Well, in fact, they're all artistic. I get that, but I mean, I can imagine these clouds moving over the course of a few hours, and so you're not going to get them to align really.
How long did that take to process, Kevin?
I probably did that one probably half hour, if that. Most of my processing is geared towards just doing it quickly, and trying not to spend much time on it.
Mm-hmm.
Now this one looks like something you took from the ground. Is that right?
Yes, I took that outside my house of a SpaceX launch. So that was that one in February, where they went and launched just past sunset. So the sunlight is still in the upper atmosphere and illuminating the clouds, or in this case, the plume.
Is this? Did you have to do much to this, or was this just you set your SLR out and click it, and you get an image like this?
I said it's a mosaic of a 4-panel mosaic, and the spacecraft has already moved on by this point. And so this is just the residual plume. And then I brought it into Lightroom, assembled it, kind of did some color and contrast enhancements.
Well, that's gorgeous. That's really nice. So, okay, and this one's Eta Carina, right? So I put this one in because it looks like a Hubble image.
Yeah.
So you're saying you're still getting used to Hubble data. That looks pretty darn good, Kevin. So this is a supernova remnant that has got these amazing lobes that are coming out on either side, and Hubble has done a great job with its various filters. This is primarily an infrared image, I believe, right, Kevin?
As far as I know, I believe so.
Yeah, and you can see a lot of the dust and the cloud features really well in the infrared. So this is the kind of image that you might take through your telescope, only not as clear nor as high resolution as Hubble's. But you could take an image like this through your telescope in your backyard and do the same kind of processing. You would need to take flat fields, you would need to take darks, you would need to remove any stray light that might be in your optical tube, and then you get it into Photoshop once you've done all that, and you make you can start doing edge detection and all kinds of fun things like that. So that's kind of where I want to go next. I want to ask you about artistic license. Once you've gotten this image with all the artifacts and stuff taken out. Oh wait, I'm sorry. There's one more. That's this one. This looks like from a Mars orbiter, but I'm not sure which one.
Yep, that's from we're using data from HiRISE.
HiRISE, okay.
It's on the Mars Reconnaissance Orbiter. So they'll take.
And that's just I'm sorry, that's just a very high resolution camera on the MRO, right?
Yes.
Okay.
And they'll take a pair of very high resolution images and work out the through the parallax method, work out the height map from it. So I take that height map and one of the those high res imagery, bring it into Maya, and I'm able to kind of render it out as as it would almost appear.
Okay. That's got to be nice. I mean, you don't have to do very much once you get it. This is already in color when you get it, or is it grayscale?
No. They've got a color strip, but it's very thin. So I'll look at that and just kind of take it as a suggestion and do color mostly as artistic license.
Is that color strip like a color table for that image? A color lookup table?
No, it's just because I guess the color sensors on the HiRISE camera are a lot thinner than the full inch or the grayscale portion of the image. Okay. So I'll look at that the thin strip and just kind of use that as a basis for what color I'm going to end up using.
Okay. All right. That's very nice image. Very nice. So let me pull this back up and I want to ask a real quick question that I saw from Ascanio Vital. He's got a really good question, and I'm going to get to the artistic aspect. Has anyone worked on old images, for example, from Voyager, Pioneer, and Mariner, to reveal new details? Have you ever worked with old data sets?
Voyager. I've done a lot with the Voyager, both Voyager 1 and 2. I haven't done Pioneer or Mariner yet.
Where can you get that? Is that from the JPL site, data site?
Voyager is on PDS. Mariner and Pioneer, I figure probably are. I just haven't looked for them.
Can you find Kevin's picture of Neptune, Tony? The images I sent you.
Well, there was quite a few. So
it's a big blue ball.
Yeah, I know what Neptune is. Thank you, Adam. I'll look for a big blue ball here in just a sec. But I want to get back. So the old data sets from Voyager, Mariner, and these old they are publicly available. You can get them, and you can go through them yourself. I saw a project once. I forgot what video I was watching, but these guys wanted to recreate themselves the Voyager flyby, I think using Juno data, and they made this really great. It took them months to do, and they finally came through. But they needed the Voyager data to tell them what they were needing. So people do use the old data sets, and you can get them. I wish I knew more about how to do that, and I could give you details on it. But unfortunately, I think if you just go to the JPL data site, you might be able to select Voyager and those missions as a download option.
You certainly can get Voyager images.
Yeah. Okay. Okay, so I'm going to go look for your Neptune image, but before I do, while I do that, can you give us some idea of, what, you've already said you've used Maya, but do you use Photoshop or any other kinds of publicly available software that people can use to kind of bring out some of the artistic elements of this scientific data?
Oh, yeah. Actually, Photoshop plays a big role. Especially with the image process, the spacecraft image processing. Once I've calibrated and run other, because I've written some scripts that will do some of the additional processing, those will be brought into Photoshop either for alignment, some touch up of any, long cosmic ray hits or hot pixels that the calibration may have missed.
So if you're pretty... I'm sorry, go ahead and finish.
And then optionally, I'll bring it into Lightroom to make further contrast and other adjustments.
Okay, and is where'd it go?
Have you lost Neptune, Tony?
Well, it's just there's just so many, and I can't. I'm just going through every single one is just going to be a little bit hard. So, oh, here it is. Here it is. I found it.
I was just going to do a dramatic reconstruction.
Here we go. There you go. Is this what you wanted, Adam?
Yeah.
Okay. Here we are.
Thank you.
Is that it? You just wanted to show it?
Yeah.
Okay, so this is from... Oh, yes, it is. And this is... so what data set is this from, Kevin?
That's Voyager 2. So that's comprised of orange, green, and blue filtered images. So there's 3 different exposures that you go and combine. And then there's a little bit of matching of the geometry because the exposure time that they had to use was a little longer than the other planets than for Neptune. So there would be a lot of rotation. So you have to adjust for that to kind of get things matching. Otherwise, everything kind of just shows up as a rainbow, given a movement between the different color channels.
This is This is a stunning image, actually. I mean, Voyager still is the gift that keeps on giving all these years. So that was really a great flyby, and it was pretty. Yeah. It was pretty surprising the details they saw on these dark spots and the cloud formations as well. So we don't have any more missions planned to go to Neptune. I don't think. There was one, I think, in the works, but I don't think it got very far. And so
no, that needs to change.
Yeah. So. This is it. This is all this, and the same with Uranus as well. I mean, we got a little bit of a flyby with New Horizons, I think, but that was not. It was moving very quickly, and so. What about New Horizons? Do you have any? Was that data available pretty much soon after it was taken, or did you have to? Was there an embargo or anything like that?
I've processed the raw imagery that was publicly available, and that came available real quick as it came down. They published it on their website, and that was mostly what I used. I didn't use any of the further, or if any of that imagery. The high resolution version of it was embargoed. But the versions that they posted were actually pretty good, of pretty good quality to be used for processing.
Yeah. So we talk about this NASA data as being available to you, but sometimes the data are embargoed for a year. For example, if you get Hubble time to take to do an observing program, you're given that time, and even NASA will pay for that time for Hubble orbits. You get the data. Hubble takes it, stores it, and makes it available to the principal investigators of that particular study, and then that gives them a year to publish their paper. And this is done with ground-based data as well, whether it's from Keck or Gemini North or CTIO, wherever it happens to be. But after that year, it's almost always publicly available. It is if it's NASA data, but other places it might have different policies. But for sure, if it's NASA data. So that's the reason I ask these questions. This data is yours, and you can use it. And I remember when I was in solar physics, I was working at the High Altitude Observatory, and the big thing at the time, and it's still up there taking data, is SOHO. It's a solar heliospheric observatory, and it's at the L1 point between the sun and the Earth. And it's following along in front of the Earth and the sun. And it's staring at the sun in a variety of wavelengths. It has 3 coronagraphs on it, C1, C2, and C3. Basically, they block the disk of the sun out, and they take a picture of the corona at different at different fields of view. And LASCO C3 and C2 were the most popular. C1 didn't always work. But amateurs were downloading this data as it was taken and discovering comets. I mean, they were just, by the hundreds, thousands of comets were being discovered using this data set. It became a thing I don't know, it might even still be a thing. SOHO, people are worried about JWST being launched at the L2 point and we're not going to be able to service it. SOHO has been up there for 25 years at the L1 point with no servicing, and it's still up there taking data. So I'm not so worried about JWST without being serviced. Hubble got serviced 5 times. It's been, it was up there 25 years. But SOHO has been up there for the same length of time with 0 servicing. And in fact, one time in the mid-90s, they thought they lost it, but it came back, and it's been working ever since. I mean, C1, like I said, is the one coronagraph that's been giving people trouble, but it takes a lot of wavelength data, and it's been replaced, or at least supplanted. Well, I don't know if that's the right word either. Anyway, the Solar Dynamics Observatory is up there taking high-resolution data now, and it's and we've got the Parker Solar Probe coming up later this year. So lots of cool things. But SOHO data is also available, and the point with that is that here's an example of amateur astronomers, or amateur, I don't even know if you want to call them astronomers, just data hunters, data wranglers, to use Kevin's term, to discover comets. And so it's possible, I suppose, that you could discover a feature that astronomers had not seen when they're, like, for example, Cassini data has been up there for a very long time. There's various Mars instruments you could look at and hopefully see things that that astronomers haven't found yet. So that's another way that you can get involved as an amateur astronomer without buying a thing, except maybe a decent computer. I mean, you probably already have one of those. So we've talked about tools. We've talked about the data. Kevin told us a lot about how he got started with it. Can you give us any advice for somebody who's just starting out? They want to be Kevin Gill. They want to start an Instagram account, and they want to show people what they can do with data processing. What is the first, what is some, well, maybe not the first thing, but what is some advice that you would give someone who's looking to do that?
I guess just don't, advice is just start with what you have, really. When I first started with it, it was just a matter
computer-wise and
of,
software-wise?
I'm sorry?
You mean computer-wise and software-wise?
Yeah.
Okay.
So
yeah,
you
don't
start
go out
with,
buying Maya and spending, how much is that? Is that like $10,000 or some ridiculous amount?
It's a lot. Currently, I'm using the student teacher license, so I've got a little bit of a discount.
Yeah, but it's not cheap. It's not cheap.
But there's a ton of free software out there, and like the obvious ones, whether it's Blender, whether it's GIMP, or both open source projects that can be used. There's tons of scripts, and it's just use those. You don't have to spend any money really with it initially. I've shared a number of scripts online on GitHub, which encapsulate a lot of my processing on there, so other people are able to generate images somewhat like I do with those. Whoa. And there's tons of free software out there that comes out of NASA that is able to you're able to use, and it's just start with the simple stuff. Start with the raw imagery, and just get a feel for it. Get a feel for what you like. Get a feel for a process, and just keep doing it.
Yeah, and that's that's a great idea. Is just grab some images and take a look at them. Try to figure out how to view them. See if you can open them up. Look at what they're like and see all of the stuff that's in there. That's great advice. You just learn by doing and trying stuff out. You're not going to break anything. It's not like you're trying to control a $100 million space telescope. You're just downloading data and taking a look. So definitely do that. What did you send me, Alex? It was this on Discord. Yeah. Okay. Questions. Achilles 308. What's it like to process an image in a way that brings something to light no one in humanity has ever seen before? good question.
It's awe-inspiring. It is one of the greatest things. When the one that comes to mind is I was actually doing an image for Cassini during the around the grand finale, time for the grand finale, and it was the image where they took Cassini when it was going through the rings and they scanned it across the edge of the planet and the rings themselves. And I started processing that, and when the view came out, and I was just thinking, I'm probably one of the first people to ever see Saturn's rings from the inside.
Oh, wow.
And it's awe-inspiring, and it's something else.
Okay. So is this what Alex? Is this Alex showing us? What is this?
Yes.
Yep, that's.
It's your artistic stuff. I like it very much, and I got many questions for it.
All right, go ahead, Alex. Give him some questions.
For example, this one is this. I don't know what comet this is. It's Comet Wild or something. Where did you get all those features from? Is it scientific data, or did it just come to your mind to put all these stones around
that's
it?
mostly an artistic view, and it's kind of based off of another image I saw of just a real messy comet or asteroid field. So I did that in Blender, and I used a 3D model that I had downloaded from the NASA 3D resources. Made a couple rocks, and then used a particle system to just kind of scatter them around. So it's not a very scientific image, just kind of just what was in my head at the time, looking at a rather messy asteroid.
Keep going, Alex. You got any other questions, or
Yeah. This one is light pollution image, I would call it.
Yeah, and that's using the night lights from.
We're not seeing it. We're not seeing it. We're still looking at the Flickr. We're still looking at the Flickr page.
Yeah.
You see that?
All I see is a Flickr page.
Okay.
Oh, I was seeing another one.
I could see the light pollution photo.
Okay, well, I'm looking at. Oh, hang on. Okay, there it is. Now I see it. Okay.
Yeah. So that was done in Maya, and that's using the Sumi NPP night lights image.
That's stunning.
These colored reflections you done on your own, or is it scientific data?
No, those are just lens glare within Photoshop.
Okay. Yes, and this is Titan, surface of Titan.
Yep, and that's another artistic one, kind of done in Maya and Photoshop. Just a matter of I created kind of a random landscape, threw some water in there.
Hydrocarbon lake.
Yep, that's right. The purpose of the model, it was kind of a water system, but you color it as hydrocarbon lake. Though I doubt you'd get that much of a glint on it that far out in the solar system. And that
I think they have detected a glint. Didn't they?
Oh, they have.
Glint, yeah.
Yep.
So you never know.
So that's
and what is this project?
So that's a camera I was building using a Raspberry Pi, and then they have a special camera for it that works pretty much like a cell phone camera, though I've got the model that excludes the infrared filter, so I can see into the infrared. And it was an attempt. It's still kind of in progress to kind of create a remote shooting camera that I can control from my laptop, and potentially control the telescope with it as well, and then eventually kind of build in some kind of dynamic processing pipelines kind of within the imagery itself, so I could do either its calibration or real-time stacking or whatever I'm able to pull off with it.
Do you have already some results of it?
I haven't the results aren't that good yet. I haven't posted anything just because at this point I've only aimed it at the moon and the Orion Nebula. The sensor is very small, so I've only got a very small portion of the focus area of the telescope. So I'm kind of working on reconciling that.
So you need something like a telecompressor to get the field more matched with the pixels?
Yes.
Yeah.
Yeah, I recently got a focal reducer corrector, and
Focal reducer.
I just haven't used it with it yet.
Okay. Wow. That, you know what? That's a hangout, guys. I want to talk about that Raspberry Pi camera in the future. I think that'd be a great topic. Just FYI.
Sure.
Okay.
So there's another flooded Valles Marineris on Mars, kind of one of the older ones, and that's using digital terrain models from the Mars Reconnaissance Orbiter, I believe. Kind of a global terrain model, and then I just got a ocean layer on there. Obviously, artistic license.
Yeah, let me just reiterate that. Astro B is going, surely this is a fake image. These are artistically enhanced for sure. So yes. These are not, there's not water sitting there on Mars like that anyway.
Yeah. And there's another one, a picture I took out of the side of an airplane with Titan and the rings.
That's really gorgeous. That's nice. Okay, so Astro B is also asking, should every image be stored with processing and source data so people know what they are looking at? Absolutely. I just want to point, yes, you need to have as much information about how that image was taken as possible. And that's what, of course, telescopes and data pipelines do. But yes. So I want to also point out that Galaxia just posted a couple of links to past hangouts that I did at the Hubble Space Telescope or the Hubble Site Channel. Some of those actually had Zolt LeVay in there detailing how he used Fitz Liberator. He's a member of the Hubble Heritage team that makes those anniversary images, the really amazing ones they put out every year. In fact, one's coming out again next month. And so definitely watch that, because Zolt LeVay goes through and step-by-step shows you how he uses Fitz Liberator. And it's really worth watching. We're going to have a whole hangout on Fitz Liberator at some point as well. Okay, well, so let me, I want to ask you one question that I'm sure you get a lot of. Well, maybe you don't. I'm not quite sure how you interact with the public, but you handle images a lot. And I know that when I make videos, or if I've posted or if I've talked about an image from various NASA instrumentation, there's always somebody who's got talking about seeing some artifact in there that nobody has ever seen before, or that NASA is trying to hide things. Do you ever get stuff like that? And where there might be an artifact left over, like you might do an image subtraction and there'll be some big black blob there, and that'll cause a lot of people to think NASA might be hiding something. Do you ever hear about stuff like that when you're doing your work?
Yeah, you get those. A lot of them are just lens artifacts that are just out of focus. You'll see a lot of rings, especially on Cassini or Voyager.
Right.
And I'll calibrate those out. There's a lot of cosmic ray hits or other artifacts in the images that you'll have to kind of clean out, or other artifacts that are on the sensor or lens itself, like Roseau marks that you want to clean out. And no one's ever accused me of hiding anything, though.
Well, I know. Well, maybe not you personally, but I guess it's like there was a solar data image that came out. It was LASCO data again, and they were doing subtractions where you subtract one frame from another frame to see something like a coronal mass ejection, for example. And this is done commonly. You take two images that are pointing at the same area of sky, and you subtract one taken earlier from one taken later, and you see the difference between the two images. And what's left over is stuff that is not in both images. And that's good for picking out detail or motions in magnetic field events, things like that. Well, when you do that, you don't get, not everything is either perfectly aligned, or there might be things like an artifact in one image that's not in another, and when you subtract them, you get some kind of weirdness, like an orb or a circle or something that looks very strange. And there were people who, especially when the 2012 thing was going around and everybody thought the world was going to end, that was an example of a planet, Nibiru, that was in orbit, and that NASA wasn't telling anybody about it. But that's an example, and the reason I point that out and bring that up here is that these images are full of all kind of crap. Some of it, most of it, you got to get rid of in some way or another, but you need to recognize that a raw image is not a pretty thing to look at. It's got dust, it's got stray light, it's got reflections in it sometimes if you've got a really poorly designed telescope. But you get all kinds of stuff in there. And when you do these kinds of processes with it to see details that you wouldn't ordinarily see, you get these other artifacts. So I just wanted to see if, you ever gotten anything or you'd heard about those kinds of things in your tenure at JPL. So.
Oh yeah, I've seen it. And I assure you, if I ever see a spaceship or something that looks like,
yeah,
like, I'll let some people know.
Okay.
Well, talking about artifacts and stuff, there's a good story from the time of the Voyager probes, when one of them was going past Jupiter, obviously taking loads of photos. One particular photo, a couple of pixels had failed, and on the image it looked like a small black monolith.
Oh, did it?
Like against the face of Jupiter. Carl Sagan printed a copy off, sent it to Arthur C. Clarke with the words "thinking of you."
That's funny. It's also unfortunate that it was that shape. Astro B's asking, what sort of CPU processor would you recommend to do this kind of work? What kind of are you doing it on a laptop mostly, a desktop?
Yeah, I'm currently using a MacBook right now.
So i7.
Yeah, and it's not super powerful. I think for the Maya stuff, I would much rather have a much more powerful GPU going forward, because right now render times can be take me up to an hour or so.
Right.
But the image processing itself doesn't take much CPU, mostly memory. The biggest thorn on my side is just running out of disk space, and Photoshop complaining that the scratch disks are full.
Okay.
So a lot of it's just disk space.
Yeah, these data are large, so you do need a lot of storage space to handle it. It's kind of like video. If you're doing any video processing, it's not too dissimilar as far as computational power. I have a MacBook with an i7. Right now I'm streaming and I'm encoding the stream. The fan is blowing like crazy, and I'm expecting the stream to die any minute. But it's it's hanging on, it's hanging in there. But when you're learning, especially, you don't need to worry about trying to download the the biggest image of, say, the entire Andromeda FAT database that they took of the high resolution area of the Andromeda galaxy. You do just take baby steps, right? And the good thing about a lot of these sensors, maybe not so much with Curiosity and the Mars instrumentation, especially HiRISE, most of these images are small. I mean, if you use old Hubble data, for example, to get started with, wide field camera, or the wide field planetary camera, tiny, 800 pixels square. Okay, we're not talking big, huge images, and you can play with those all day long. What is HiRISE? HiRISE is like the most high resolution, biggest images they have at Mars right now, right?
Yeah, and I believe if you had that camera around Earth, it would be considered a spy satellite.
Yeah.
It is that high resolution. The images I've been working with, those are upwards to about 1 or 2 meters a pixel.
Yeah, so there you go. But even if you wanted to get DCAM data, which is a dark energy camera data that's from Cerro Tololo, that is 500 megapixel data. It's big, but you could handle that pretty well, I think. So anyway, real quick, you're a software engineer. I feel like, Kevin, if I had met you when I was still doing my day job from the year, we probably would have got along really well. You handle data, you work with data pipelines, I'm sure. Couple things I got to know as a software engineer. First of all, did you get a PhD?
No, I've got a master's degree in computer science.
And I did not either. And I point that out because people ask if they can get jobs in astronomy. And I always tell them the advice I give you is, yeah, you can become an astronomer with a capital A if you get a PhD, but that's not the only way to get a job in astronomy. Both Kevin and I were software engineers. I had a very fulfilling career writing code to process images, to take data from cameras, to run data pipelines. All of that was very exciting and fun, and it doesn't require a PhD. Now, I only had a bachelor's degree, so Kevin got a master's, but you don't need to keep going if you are good at or if you're interested in writing code to control cameras and process data. It is a way to get a good job. And it's in demand, wouldn't you say, Kevin? I mean, if you can process data, or write code to process data, that's a pretty strong skill set. You're going to be in. I'm not going to say you'll get hired right away, but you'll certainly get a certain consideration.
Yes.
It's an in-demand job, and also the same thing with if you can build things, like if you can build a camera, if you can build instrumentation, that's also high in demand. Okay, but really, here's what I meant. Here's where I'm going with all this, Kevin, and it's important. So think about these answers. VI or Emacs?
VI.
Good. Spaces or tabs?
Spaces.
Ah, good. Do you like Python?
Python, yes.
Okay, good. Well, we would have been good friends. I would have liked. Yeah, all those are right. VI for sure. I don't know how anybody can use Emacs, but people do. And this business of spaces or tabs, it's also important. If you don't know what I'm talking about, you will when you start writing code.
Yeah,
okay.
Open up some code written with tabs in one editor and then try it in another editor.
Yep, it's like, what? What are you doing? So no, and you can't write good code with tabs. I'm sorry, you just can't.
No,
but Python kind of forces you to. So I had to have a long sit-down talk with Python before I embraced it, because it was forcing me to write code in a way I wasn't prepared to write. I had been a Perl programmer for almost 20 years too, and that gets you into all kind of bad habits. So
oh, yeah.
Going from Perl to Python was not a pretty thing. So
the trick with Python is you got to use tab emulator, where it just inserts spaces instead.
Yeah, it forces you into that
Yeah.
zickiness. So, okay, you guys have anything more? Alex, John, Adam, any more questions you got for Kevin? Running out of time.
Not a question. I'd just like to give a shout out to Judy Schmidt, because she does excellent tutorials for people that might be interested in getting into image processing. People can find her tutorials at photographingspace.com.
Yeah,
and I would absolutely recommend the tutorials on the Planetary Society's website.
Ah, good. Yeah, I had
a lot of them are written by Emily Lakdawala, and that's how I got my start. And eventually, I'm going to screencast doing some image processing myself, but haven't got around to that yet.
Now, Judy doesn't know it yet, but I'm going to ask her if she will come on a hangout and show us how to do some of these things in a very step-by-step way, because she's really good at that. And in particular, I want to ask her to show us some software like Fitz Liberator, but I haven't asked her yet. But Judy, if you're watching this, get ready. I'm going to reach out. So hopefully she'll agree to join us in a future hangout. And yes, the tutorials on the Planetary Society are also definitely worth checking out. Emily is awesome. I talked to her on one hangout many years ago, and she's great. So definitely check out the stuff she does. And most of their stuff, however, is all planetary related, planetary science related. So anyway, okay, I gotta show you guys something. I'm very excited about this, and Elliot may be getting mad at me if I show him this, but this is something that's coming down the pipeline here at Deep Astronomy. We are designing this JWST clock, which I'm going to be selling in our shop coming up soon. And there's a preview of some of our new logos that are coming out too. In the bottom, there's the new Deep Astronomy logo. So keep an eye out for this clock. We're going to start selling it soon, before hopefully. But yeah, this was designed by Elliot, who's just come on board at Deep Astronomy, and I saw this last night and just about went nuts. I just couldn't believe it. So I just wanted to share that with you guys. That's coming down the pike, and future Hangouts ideas that we're going to be talking about. I think next week or next time we might talk about observatories. Right, guys? You want to do that? Building an observatory in your backyard?
I know a few people that a local astronomy club that have built their own observatories.
Yeah.
Get one of them on.
Okay. Well, that sounds like a good job for you, John. Thank you for volunteering.
I think Adam knows them as well, or not know them.
We'll drag someone on the show, I'm sure.
Yeah, good. So we want to talk about whether or not you should build an observatory, the advantages and disadvantages of doing that, and what you can do with an observatory that if you didn't have one, you couldn't do. So we'll talk about all that stuff as well. I also want to have a hangout in the future on this Raspberry Pi camera. I don't know if we can get Kevin back, maybe in the future, to talk about his progress and success, but I want to dive into that a lot more too, because that Raspberry Pis, by the way, are only $35, right, Kevin?
Yes.
So the computer part is not that bad. What was the sensor that you bought that went with it? What was it called?
It's the what do they call it? It's the no IR camera for the Raspberry. I forget what they made it specifically for the Raspberry Pi.
Okay.
And I think that was only another $30. So
we're at $70 here, folks.
Yeah, and it plugged right in. They've already written the software for it that you just kind of install the packages. And
we should have a hangout on that, because that sounds like something amateurs like us need to be doing, and I want to learn more about it. So, all right. So anyway, folks, that is it. Kevin, thank you so much for joining us. I hope you'll consider coming back in the future and talking some more. Thank you so much. All right. And
I could sit here for days and just look at Kevin's images.
Yeah, I could tell.
What is the most important image ever taken, in your opinion?
Good question. Good question.
Oh God, it's almost impossible to narrow down all of those images.
Not for me.
Hubble Deep Field.
Hubble Deep Field, the pale blue dot from Voyager.
Mm-hmm.
Cassini's image from behind the planet. All of those.
Do you miss Cassini, Tony? Kevin, sorry.
I do.
Yeah.
It was a beloved spacecraft.
Yeah. How about you, John? What's the most important image you think was ever taken so far?
I think Pillars of Creation.
Pillars of Creation. You like that one? How about you, Alex?
I think it's Hubble Deep Field.
It is Hubble Deep Field, folks. I even made a video about it. Okay. All right, folks. Well, that is it for this Telescope Talk Hangout. I want to thank our guest, Kevin Gill, who is a software engineer at NASA JPL. He also does image processing on his own. We've seen some beautiful pictures. Check out his Instagram account. Follow him on Instagram. Also, check out his Flickr stream. Lots of images being posted there as well. Thank you guys for watching, and we'll see you guys next. Tomorrow's hangout, we're going to be talking with Astro Coffee, with Carol Christian, and some people who have used solar data to find out some pretty cool things, and we're getting that finalized right now. So I'll see you tomorrow at 3 o'clock on our Astro Coffee hangout. Okay, thank you all so much for watching, and as always, keep looking up.